Good morning, ladies and gentlemen, boys and girls, friends and neighbors. Today we're going to look at Bob's composition of functions assignment. This was assigned yesterday on Monday. Today your assignment is to watch this video, check your answers to Bob's, and use these answers to help you with Jamal's. I'm not going over the answers to Jamal, so you could consider Jamal's as being a take-home quiz, if you will. So let's jump into Bob's. I'm going to try to limit this video to 20 minutes roundabout. So let's go to number one. Consider I want to have these two functions, discrete functions, where f consists of 3 ordered pairs, g consists of 3 ordered pairs, and I want to find f of g and g of f. They don't exist. We're going to explain why. Here you go, number one. Alrighty, so if I want to find h of x, f, keep in mind anytime you want to pause the video, go ahead and pause it and write some stuff down. So part one was, hey, let's find this h of x, which is f circle g, which is f of g of x. Here I have to look at the domain of g of x because g of x is on the inside. Looking at the domain of g of x, the x values of g of x, I see that that is 2, 4, and 0. So therefore, I can only take h of those 3 numbers. H of 2 is going to be f of g of 2, and I look at my table and I see that g of 2 is 3. And what is f of 3? F of 3 happens to be 4. So therefore, I have a starting value and an ending value, and this 0.24 is the first point on this function f circle g. In like manner, I take h of 4 because 4 is in the domain of g of x, f of g of 4, and again I see that g of 4 from my table is 5, and I also notice that f of 5 is 0, so I have my second point. Input, output, I have 4, 0, the second point on f circle g. In like manner, I have h of 0, which is f of g of 0. I look at 0 because it is the last value in the domain of g, and I see that g of 0 is equal to 1, f of 1 is 2, and I have my third point on f of g, input, output, 0, 2. In like manner, if I want to look at the function g of f of x, since f of x is on the inside, I have to look at the domain of f of x. And I look at my table of 3 points, and I see the inputs are 1, 3, and 5, the domain of f. Therefore, I can only take s of these values, s of 1. What's f of 1? F of 1 happens to be 2. Therefore, I have my first point on g of f, which is input, output. And this bad boy right here happens to be 3. Little notation error there. And I can do s of 3 because 3 is in the domain of f. I see that f of 3 by my point. F of 3 is 4. I see that g of 4 is 5, and I have my second point on g of f, 3, 5. Keep in mind we did do this last week. This is just the second time we've done it, so we're okay. Again, I can take s of 5 because it is another input of f, which is the inside of this composite function, and I notice that f of 5 is 0. 5, 0 is on f, therefore, and g of 0 is 1. So I have my third and final point, input, output of the function g of f of x. Alrighty, going to number 2, moving right along. If you need to pause the video, go right ahead, feel free. So here I have 2 functions. I have this f of x as this quadratic function. 2x squared minus 3x plus 5, and this linear function, 4x minus 1 is g of x. And again, I want to let h of x be f of g. And so wherever I see x in f, I'm going to put g in here. So I have 2 times 4x minus 1 squared minus 3 times 4x minus 1 plus 5. Do the algebra. 4x minus 1 squared is going to be 16x squared minus 8x plus 1. Multiply by 2. Pause the video, write it down, follow along. Bam. That's h of x. That's the function f of g. S of x is going to be the function g of f of x. So wherever I see x in g, here's g. Wherever I see x, I'm going to put f. So this is going to be 4 times f of x right there, minus 1. This simplifies distributive property. 8x squared minus 12x plus 20 minus 1 is, bam, 19. And that's number 2. Number 3 is an easier version of number 2. Number 3 is I have, you know what you can always do, ladies and gentlemen, and you know it, and I've said it before. You can go here and pause the video. Okie dokie. And let's do an easier version of, here I have 2 linear functions. I have f of x is equal to 1/3 x plus 7. I have g of x is equal to 3x minus 1. I want to find, again, h of x, which is going to be f of g. So wherever I see x in f, I'm going to put g. So this guy right here is g. And I simplify that. 1/3 times 3x is x. 1/3 times 21 is negative. Ooh. Here I have f of g, which is equal to x. That's interesting. That's going to be very interesting down the road in a couple days. And so here on the next one, I want to find s of x, g of f of x. So wherever I see x in g right here, I'm going to put f. What is f of x? 1/3 x plus 7. Do the distributive property. 3 times 1/3 is x. 3 times 7 is 21. 21 minus, ooh, I have another one. So here, look what happened. Here, I saw that f of g of x equaled x, and that's also what g of f of x equaled. That's an interesting and very important property that we will talk about Wednesday. Well, let's go on to number 5 or number 4. Here I want to find the composition of specific values. F of g of -1 is going to be f of g of -1. Here I have to find g of -1 using the function g. That's going to be 3. F of 3 is going to be, you're going to put 3 in for x. 3 squared minus 12 plus 7 is 4. Bam. And B, here, I want to find g of f of 2. G of f of 2, I have to find f of 2 first. F of 2 is 2 squared minus 4 times 2 plus 7, which is 3. So this is going to be g of 3, which is 11. For C, I want to find g of f of 5. That's going to be g of f of 5. So I have to find g of 5. And what is g of 5? 2 times 5 plus 7, 17. Using my calculator and putting 17 into f. F of 17 is 17 squared minus 4 times 17 plus 7. Using my calculator, and I see that that is 228. And D is going to be g of f of -2. Here I have to start off with finding f of -2. F of -2 is -2 squared minus 4 times -2, which is 19. So I'm going to find g of 19 because f of -2 is 19. G of 19 is 2 times 19 plus 5, which is 43. Zoom out. Push out of the page. Entire page. These are all the answers for number 4, A, B, C, and D. And we have one more problem. Zoom out. And number 5, I want h of x is f plus g of x. I'm just looking at this. Since I'm adding that, that's going to be 2x squared plus x plus 4. S of x is g times f of x. Here I have, this is g, this is f. I'm going to use the distributive property here. 4x minus 1 times 2x squared. 4x minus 1 times negative 3. And 4x minus 1 times 5. Using the distributive property again, I get 8x cubed. Going this way, minus 2x squared. I have negative 3x times 4x is negative 12x squared. Negative 3 times 1, negative 3x is positive 3x. Do distributive property one more time. 5 times 4 is 20x. 5 times negative 1 is negative 5. Simplify the like terms. Looks like I get 8x cubed minus 14x squared plus 23x minus 5. H of x is going to be f minus g. F minus g, I'm writing this down and I'm making sure that I'm putting a parentheses in front of g because it's minus g. This is f minus g. I use the distributive property on the negative sign. I get negative 4x. Negative makes it positive. Add, simplify this expression here. I get 2x squared minus 7x and plus 6. That is f minus g of x. R of x is going to be f divided by g. F is 2x squared minus 3x plus 5. G is this linear. And what do I have to do when I find a quotient function? I have to check the domain. And what happens with the domain? The denominator cannot be 0 because you cannot divide by 0. So I set the denominator equal to 0. Solve this little itty bitty equation. Add 1. Divide by 4. So x cannot equal negative 4. And that's the domain of this quotient function. Okay, so let's zoom out. Look at this entire page. Our page, that's number 5. Keep in mind, Jamal looks exactly like Bob. Number 5, number 4, number 3, Wednesday, number 2, and number 1, which was probably the hardest of the problems. And there you have a video for, you can always pause this. You have a video for Bob. And tomorrow you're going to watch this video about Bob, check your answer. Or today you're going to watch the video on Bob. And then you're going to do Jamal. And hopefully, well, Jamal will be homework and quiz points. So have a good day. And I have no idea when I will see you. A bunch of snow out there. Good day.